In lesson 3 of programming 1, we're going to do conditional executions where we will learn the if statements, while loops, programming, or problem debugging. We might do Boolean values. I'm not sure if I'm going to be able to explain it or make examples of it, but I'm going to check. And then we have nested if statements and the for loops and the nested loops, right? Okay, so conditional executions, this basically means, or conditional execution means the computer only executes certain certain codes of if a condition is true. Right, so the computer will only execute certain codes if a condition is true. If you think of making decisions in everyday life, if it's raining, you take an umbrella. If it's not raining, you don't take an umbrella. And the computer basically works the same way. Right, I wrote down a little syntax for you that has to do with the if statements and how it works. So basically, an if, so things like your ifs, your switches, your whiles, your for loops, those are all conditions that we're going to basically use, right? So if obviously you're using a condition, you'd have a condition inside the brackets, and you'd use the curly brackets to enclose what happens with that condition, basically. So if that condition is true or met, then there would be a conditional execution, right, for that code. So that's basically what I mean. And I'm just going to make an example using the if statements. Okay, for example, if maybe, obviously you would have your hashtag include using namespace, STDs, and the int main and all of those. So I'm just basically stating what would go inside the int main, right? So you just have to also know what your outside or your window should look like. So you would have, let's say, int age being equal to 20, say 20 for example, and then let's say if age is greater than or equal to 18, then obviously this is now the condition. If the age is greater than or equal to 18, and now I'm gonna tell my computer what I wanted to do if obviously the condition is true, right? So what code? So I want my computer to print out for me or compile this: you may eat. Right, and then after you close it up to show that you're done with whatever you wanted it to compile for you. So if age is less than or equal to 18, you may eat. Looking at this, because this condition is met, I mean the int or the declaration was 20, so now obviously the condition is met. That would mean the person can eat. So you would have now the output. Just gonna write it here. Output would now be you may eat. Right? So this would be the output. Outputs is whatever that's inside this, and I was supposed to have something like that, but yeah, you can eat, like that. Okay, so that would be the if statement. But sometimes you have more than one possible outcome. So like what would happen if I'm not 18, or what would happen maybe if I'm like, I don't know, let me see, what would happen if I'm 17 or something, or if I am 20 something, man, because now this is talking about people who are over or equal to 18, but obviously less than or equal to 20, right? But what about the people that are less than 18? So they would also have to have maybe their own if statements, and that's where we have things like our so we dealt with this, so that's where you have things like your else ifs and your else, right? So now you'd have more things to do. Now I wrote down the syntax for that. So if you have a condition, the computer is going to, if this condition is true, so if this condition is true, the computer will compile this statement that you have. If it's not true, so if let's say you had people that were less than 18, for example, less than 18, the computer would now have to come here to this condition, right? And then compile the statement. But if maybe, for example, you had people who, I don't know, let's say are less than 10, it will basically compile the statement. The else basically means if both of these are not basically what the conditions basically don't fit your, don't know how to explain it. If the conditions do not fit what you want or what you want to execute, then we would just jump to the else. So if this isn't working, and if the else if is not working, let's just compile whatever that's left. So whatever that's left, we want that, right? So I'm just gonna make an example with marks, for example. Yeah, let's use marks. So let's say you have int and the mark, right? Let's say the mark is 40. I'm just gonna close it, and then I'm gonna start my if statement. So I'm gonna say now if maybe the mark is greater than or equal to 50, which obviously you can see it's not going to work because we declared a 40. So now we have something above 40 or even equal to 50, which is not true, right? So I'm saying now if the mark is greater than or equal to 50, the statement here would be C out. Let's use pause. Don't have space, so I'm just going to close it off like that. And then I'm going to say else, or it basically kind of means or else or otherwise. So, but you write it as else, obviously, or else fail. So let's use, you actually have to have the C out. Okay, let me fix that. So you would have C out, fail. Don't know what I'm doing. And basically with this, because now we look at our declaration, we declared a 40. The first if statement says if the mark is greater than or equal to 50, the learner maybe gets a pass. And we can see that this is not true because the learner got a 40. So, or else if the learner got anything below that, right? Anything below that, that's a fail, right? And that's how you basically, so the output for this would basically be fail. Right, so that would be fail. If you think of the real world applications, like your, I'm not sure if I wrote it here, okay, yeah, ATM. So if you're dealing with the ATM or any bank and you want to insert your PIN, maybe they let's say they set it to be, if the PIN is correct, you're going to be granted access maybe to get your money or do whatever you want to do, right? Or else the screen will display incorrect PIN. So if it does that, obviously you'd have to then try other passcodes you might have. Right, an example. So if let's say in the exam they give you something like this and they say to you write a code, or yeah, something like that, write a code to like basically showing this and maybe using user input. So I think I'm going to use user input. Obviously I'm writing down, but you can use your laptop to check or verify some things. So if you have maybe int pin, I'm just going to declare pin, and because I want it to be user input, I'm not going to say what the pin actually is. Let's say C out, please enter pin. And let's say we want the pin to be 3 digits. So 3 digits. Right? And then we have to have the CN pin. And now I'm just going to use the if statement. So I'm going to say maybe if pin is, let's say, greater than or equal to 125, for example. 125. And then I'm going to have a statement, C out, access granted. And then I'm going to close this because now the statement is done. Or else, if obviously the pin is below 125, that would mean, let me write it here, C out, incorrect pin. And I'm just gonna close it off there. Okay, so if you think about it, they said if pin is correct, you're going to be granted access, or else display incorrect pin on the screen, right? So you have now to declare pin because we're using pin, right? And then it says please enter pin for with 3 digits, and you'd enter that. And then you have the CN for the user input. And then now the condition is if the pin is greater than or equal to 125 or 125, access would be granted. If not, we're obviously going to skip this first the first if, which is this line. So we're going to skip that and move on to the else, right? If you wanted to use else if, that would be if you have many different kinds of options, right? So, but for this case, we only had 2 options. So I'm just going to use the else, and that would be if you have incorrect pin. So you can try it on your own and see, maybe try plugging in for the CN here. So here, try plugging in different kinds of numbers. So try a number that's way smaller than this or way bigger than that, and see what the screen basically displays. Right? I'm just doing it like this because I might not have enough time. Or if you were to think of maybe online shopping, if you maybe they set the system as maybe if payment succeeds, confirm order, else show that payment failed, right? And you would have things like maybe if you're paying online, if obviously you have enough money in your bank account, it would take you to different options now. Maybe, I don't know, something, you would have a lot of different things. You'd have maybe your address, because obviously they would have to deliver. But if maybe you didn't have money in your bank accounts, then it would show payment failed, and then obviously you wouldn't be able to move forward with the online shopping or payments. So you'd have things in your carts, right? So okay, I wrote the Boolean values in my book, but I'm not sure if I'm able to explain it the way I wanted to. It's very simple, but I don't know if I'm able to explain it right now. I know I do computer systems, but yeah, I just can't. Okay, so for nested if statements, so that's when you have an if statement inside another if statement. For example, oh, I didn't write it here. So for example, if you have maybe, let's say int, and we're dealing with age, let's say equal to 20, and then maybe a bool. So try doing your research on what a bool is, or boolean values, and yeah, maybe the bool has ID. Let's assign it true. And then my if statement would be an if, obviously with a condition. Let's say if age is greater than or equal to 18, then we want to execute this. So you would want to execute something, so you would have opened curly brackets. But now I want to also give another condition. So if we have that condition and it's true, I also want to assign another condition. So if also you have an ID. So let's say it has ID, then now the execution should be cout would be the entry allowed is allowed, right? And then obviously, oops, I don't have enough space. Maybe, okay, you would want to close that, and let's say on another line you'd want to close that. So this goes with this, and this goes with that. So you have to check your curly brackets. You have to have a pair of curly brackets. If maybe this was not there, you would have an error, or maybe this one was not there, you would have an error because this encloses this opened bracket, right? So that would be your nested if statements. So if you're 18 and I want to, so if you're 18, you can enter, or sorry, so if you're 18, I can give you a chance, but if you also have an ID, then you can enter. It's kind of, if you have this and you also have that, then you can enter, instead of maybe writing it in if 18, sorry, if age is greater than or equal to 18, you can have here your and, so you can have and has ID, so you can write it in one condition, but if you want to make it a lot of different conditions, this is also fine. It's also acceptable, right? Also, if you think in real life, maybe at an airport, if you have a ticket and a passport, then you can board plane, right? So those are two conditions. If you have this and that, then you can board, right? Okay, let's do our switch statements. These are basically used when you're choosing between many options rather than having conditions, right? So you have a lot of options that you're choosing from, and you would use this. Okay, I didn't write anything. So for example, let's say int, let's declare an integer day. We're calling it day, and we're choosing 3, right? So we just left a 3. So switch, to show that you're using switch statements, and our option, we're going for day. So day is the kind of what we're choosing between, right? So we're choosing days. So this is how you write it. So you're going to open up your brackets, and then you're going to have case 1. So it's more like a syntax or formula that you kind of have to follow. Case 1, maybe cout, say Monday. And then to close off this option, we use break. Give it a break, right? And then to show that we're now looking at another option, you would say case 2, and then check what the option is, or the case is Tuesday. Remember, we're talking of or about days, so it has to correspond. To show that we're done with this option, or this was just option 2, close it off with the break. And then now, to show that we have another option 3, you say case 3, you do your cout, then you'd have the Wednesday, and your break. And then if you're done with all the options, you would close off the, I don't know how to call it, but you'd say default, right? To show that there's no more options that you going for, like you're done. So you'd go default. Obviously, if you're not choosing any of the options, your default would be this. So this is kind of your last thing. If all of them don't work out, maybe we say in valid, right? And then we close off. So this would be more like your switch statements, or what it has to kind of look like. You'd have your cases, which is more like your options, and below those options or cases, you would have the statement for each case, right? And then to close it off, we use a break. The default basically is more like you saying, Ahmed, nothing here works, so I'm just gonna go for the last option, and which that would be invalid, right? In this case, it's the option is invalid. And yeah, so our outputs for this would basically be option 3, Wednesday, because we chose day 3. So our day was 3, day 3 is Wednesday. So output here, because C out says Wednesday, the output would be Wednesday, right? And so that's how it works. Let me just write output. So output is basically Wednesday. Okay, everyday examples would be, if you think of maybe ATM, they would obviously set the system to give you options, right? So when you're going in there, you would either have to, maybe you're withdrawing, you're depositing, you're maybe checking your balance, or you want to exit something. So you would have options, or different kinds of options. If obviously all of these didn't work for you, you would basically choose exit, right? So that's kind of the everyday kind of situation you might deal with. Not every day, because you wouldn't go every day to an ATM. Let's look at number 5. Where we're doing the while loops. So a while loop is, a while loop basically repeats code while the condition remains true. I'm very sick, so I'm not sure if you guys can hear me properly, because I can't even hear myself. It's kind of like my ears are blocked, my nose is blocked, and yeah, so pressure is not equalized in my, is it the Eustachian tube? I'm not sure, don't remember, and I passed life science so well, but I didn't go for it. Okay, the syntax here would be, so for a while loop, this is kind of like a formula. So you'd have while the condition. So if this condition remains true, you would have the statement being your output, right? So for example, if you have, let's say, int I maybe being equal to 1. So let's use a while loop. So we're going to say while, and then the condition is I less than or equal to 5. C out. So this is more like the statement that we want to execute. So we want to execute or bring out the I, and then I'm just going to explain what I'm doing here. So while I is less than or equal to 5, we want this, and the computer is basically going to do that. And then after that, it's going to check the next line. So the next line is basically saying increment or go up by 1 every time, up until you are less than or equal to 5. So it will keep doing that until it's equal to 5, but it's obviously going to start at 1, because we're saying I is equal to 1. So it's going to keep doing that and that and that and that up until it's equal to 5. So remember, a while loop repeats itself. So the computer is going to check this condition, prints out this, and then look at this, right? And then it basically goes back and does the same thing while, or loop, 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 up until it's done, up until this condition is met, basically. Okay, so here the output, let me write it here in red. So the output here would be, so it would start with a 1, and then it checks here where it says go up by 1 again, then it goes to 2, it checks again, 3, 4, and then 5. It's going to write it in a line going down, so it's not going to come up like that. I just don't have space. So you would have 1, 2, 3, 4, 5, like this, until. So it's a loop. Like if you think of maybe when you're converting, let's say, a decimal to binary, when you're doing the divisions in computer systems, the computer would keep looping, or you would keep looping by dividing up until you meet the condition of a 0 and stuff like that, if obviously you're doing the conversions. If you think of an real life example, a washing machine keeps washing while there is still time left. So as long as there's still time, obviously when you look at a washing machine, there's like time there, and it tells you how long it's going to wash. As long as that's the time is still on, it's going to keep washing, right? So it loops and loops and loops and loops and loops. And then let's talk about the for loops, and then after that we do the nested loops, and we will be done, right? So for loops basically, or a for loop repeats code a known number of times. Remember, the while was while the condition is still true. So for this one, we know how many times we have to do it, right? For example, if maybe, I'm just going to use the same example like I did with the while, and I'm going to explain why it's called the for this time, right? So if you have for int, let's say I being equal to 1, so I'm declaring it. Why don't I have space? So I declared it, and then the condition is I is let's say less than or equal to 10. Let's use 5 actually. 5. And then we say, let's say increment I by 1 every time, right? So that's the for loop. And I'm going to explain why it's the for. Let's say the C out is basically I this time. So it's just I. Remember, with the while, we had the this I and then we had the increment, right? So this time we just have this. We call this a for loop, or we say a known number of times, because obviously the computer would first look at this line, and then it sees everything at once, right? So it sees that we have to increment, it sees the condition, and also this at the same time. So it would know how many times it has to do something. Unlike the while, where it first obviously has to look at this, which is good, and then this. And then after looking at this, it has to look at this, and then hop back to that, and stuff like that. So a while basically is more like while the condition is still true. So keep doing that as long as the condition is true. And then for this one, it's more like um we know how many times we have to do it, so I don't have to keep checking and checking until the condition is met, basically, right? So that's a for loop. And then for the nested loops, which is the last thing we're doing for tonight, nested loops is basically a loop inside another loop, if you get what I mean. For example, it's more like, it's also the same as the nested if statements, but this time for the loops. And I'm just going to use a for loop instead of a while loop, because the while loop is quite long. So let's say you have for, let's say int. So we're declaring maybe rows 1, and then the condition, and then the increment, right? So for this and the rows are less than or equal to 3, we increment them. And then obviously I have to now open up for statements or what I want, and then I have another for. So now the computer is going to first look at this, and if this is true, it now also has to look at this condition and then print out whatever that's supposed to be printed out, right? So for, let's say int columns equal to I1 actually, and then let's say columns greater than or smaller than or equal to 4, and increment. And then now obviously I have to have a statement inside, so C out. Okay, remember this has to go with this, that has to go with this for your code to obviously work. If it doesn't, if you don't have, let's say this one, you would have a programming or a program debugging, which means you'd have an error. That's what I wanted to explain with the debugging, but I don't think I might have time. So for this now, the output would be, let me use. So the output here would be, because we said for the rows, it has to start at 1. We have to have up to 3 rows, and it has to be incremented, right? Okay, so we have row 1, right? And then it's so we have to have, so it says the rows start from 1, and then obviously rows go this way, so rows go that way, right? Remember, so because of that now it also says, so the condition also says the rows should be less than or equal to 3, so we have to do that up to 3 times. So 3 times. So now we have 3 rows, and then we check the other condition, right, which is the columns. So we have to start at 1, so column 1, and then they have to be less than or equal to 4 and be incremented. So if this is column 1, we have to have column 2, 3, and 4, right? So you would have column 1 like that. So you basically have those. So this is basically your output. I'm not sure if I'm explaining it correctly to somebody who might not understand this to their best ability, but this is the best I could do for tonight. Right. Next time we're going to be doing functions, and hope I don't know what else comes. But yeah, thank you so much for watching.